I'm going to quickly go over the synapse, as well as a couple other things, and then move on from there. So first things first, the synapse. This should be familiar from the muscle chapter. All it basically is this thing, if we remember. Right? Except it's not on a muscle this time. It's actually on a neuron, right? So pretend this is the dendrite, right? Okay. The steps are essentially the same. You know, you still have your ATP, you still have calcium going into the synapse, and of course the synaptic cleft. Same deal. This is where it's a little bit different. When we were talking about the muscles, this was acetylcholine inside, which is a neurotransmitter. However, when it comes to neurons, that's not the case. This could be acetylcholine, or it could not. The thing is, it could be any other neurotransmitter that you guys are going to be going over. But all you have to know, basically, is the steps are essentially the same. It's not always going to be acetylcholine, it could be something else. But same stuff. It diffuses across, except this time, it's not binding to a muscle, right? It is binding here, right? Onto our neuron, so that it can send signals down our body. Right? Basic stuff. I'm not touching too much on this because I feel like most of us know this. Of course, if you have questions, please go and ask. I'm going to move on, though, to the more, I guess, intensive things you have to know from this groups of slides. Alright. Let's kind of erase this. Alright. So, if you're following on the slides, we have two things here. So I'm trying to make sure it's not in the glare. EPSP and IPSP. These two things show up on your slides. These stands for excitatory postsynaptic potential, inhibitory postsynaptic potential. A whole bunch of nerd words. Really, all you have to know are these two right here. Right there. The E and the I. What do they stand for? Well, excitatory, inhibitory. Right. And then postsynaptic potential, we can kind of assume postsynaptic after the synapse. Potential, we know is action potential, right? So it's after the synapse, it's the potential coming down on the dendrite, right? Or the neuron. So, there are a bunch of different kinds, but as we go through them, I'm going to go ahead and visualize it for you guys right here on the spot. So, first off, we have the first one down here. Right? And it looks a little something like this. This is no summation. So, but what does that mean, right? So we can take the root word from this. Summation, the sum of things get added together, and you have two of these. So all you really have to know that for no summation, it's two or more EPSPs, excitatory. So in layman's terms, two more EPSPs that do not add up. So you can see is one here, another one right here, but they don't go past threshold. If you remember threshold, when it surpasses threshold, you have it shoot up and you get action potential. So there's a little thing here, a little thing here. But what does that look like? So let me draw it up here. You know, you have like that. It's a really horrible neuron, right? But you would have another, so these are the little tails of the synapses, right? Let me just see if I can draw that. But there would be some attaching up here, right? So like, let's say this one right here. So what this would be a signal being sent down this towards the other neuron, but they're being sent so infrequently that they don't add together, basically. Now, your other form looks a little bit like this, right? So what this is is your temporal summation. So what we know, again, using the root roots here, when I look at the word temporal, I think of temporary things. Certain things are temporary like at different times, right? So basically for this, it's two or more EPSPs that add together. So what this will look like up here is coming out from another neuron. Remember, another neuron's synapses are sending this. You would have, instead of one signal after another, you would have multiple together. So you would have boom one and boom one followed right after the other. So it's multiple signals coming down your neurons. Once they get added together, they're added together so quickly that they surpass threshold, and that's where you get it shooting up to action potential, right? All right. So these last two, they're sort of related. So I'm gonna go ahead and do like a little squiggly line here, just so that we can kind of put these two together. They're all related, but these two are more closely related, if that kind of makes sense. So let's see. Right? First off, we have spatial summation. Right? So spatial summation, it's kind of the same thing where you have multiple signals, except we'll see what it is. Two or more EPSPs from multiple synapses. And what this looks like is kind of the same thing here, right? You're still going to reach that threshold, right? I should have drawn the arrows here. Right. But the thing that makes it a spatial thing, which, if you think spatial, different spaces, right? Instead of having one synapse reaching this neuron, you're going to end up having another one. And they're both sending excitatory signals into the single neuron here. And that is spatial summation. This guy sends a signal, this guy sends a signal, and they both add up, and that is spatial summation. Kind of the same thing, there's just a special name because there's two instead of one. Alright. This last one, it's kind of the same thing. Still spatial summation, but you have your EPSP / IPSP. What's the word I'm thinking of? Counterbalance? Contradict? Basically, these guys go against each other. So, let me erase this guy down here and illustrate it. It would be something like this, right? Something similar to that. Yeah. So, for spatial summation, it's two different dies coming. For the last one, you're going to have one EPSP, an excitatory, coming here, but you're also going to have an IPSP, an inhibitory signal. And it's coming here, right? So basically, one neuron is telling this neuron, do this, the other neuron is telling this neuron, don't do that. And they cancel each other out. So if these two were both EPSPs, they would have added together, you would have gotten this, an action potential. However, since one of them was an EPSP, you got inhibition, and it went away. The best way I describe this is kind of in decision making. Like, for example, if you're driving down the highway and you're trying to decide when to change lanes, you don't automatically go without thinking about it. You have different signals in your brain firing off when to do it. You have certain times telling you to do it now. It's like when you second guess yourself, That's one way I like to think about it. So that's why I think about an IPSP as that, and EPSP is sort of when you do the action. Another way I would say is these guys, right? Temporal, summation, spatial, these are all things in action. So me doing this with my hands, all this is happening. My brain is sending neuron signals down through the neurons, a bunch of EPSPs to say, hey, write this, talk about this. But, they're kind of the same thing. The main difference, though, as you can see, this goes down, right? And we remember an action potential and all that we need to go up to get action potential with depolarization, right? So, if there's one thing you can remember about this is excitatory, and just remember local depolarization. And we remember depolarization is going up, right? This is all depolarization. This is depolarization too. Any form of going up is a form of depolarization. But here it goes down. Inhibitory, just remember also, it's a form of local hyperpolarization. And these are the kind of things that your brain sends signals out to that impacts your decision making and stuff. But that's kind of basically how the synapse works, to send signals, and this is all done through, if we remember, like the muscles use acetylcholine, right, and the synapse uses certain things. It sends little neurotransmitters, those little dots in between. And when we get into the neurotransmitter chapter, we can see what they all do, and it's pretty cool because you get to see, well, acetylcholine you need obviously for your muscle movement, but then you're going to see, oh, serotonin does this, all these other crazy things, and how they interact thanks to the way your synapse delivers them throughout your body.